Okay, in the previous section, it was the structure of the basal ganglia. So there are so many different diagrams given in different books, but if we try to draw the sketchy diagram, we can draw it like this. Like this is the central line, and on either side of the central line, this blue one, this is the thalamus, and then the other thing with respect to the basal ganglia was internal capsule, and internal capsule is like, say, this is the pathway of the internal capsule, this way, this is how it travels. So medial to the internal capsule is caudate nucleus and subthalamic nucleus. Subthalamic nucleus will be medial to the internal capsule but below the thalamus. And what about the caudate nucleus? Caudate nucleus was medial to the internal capsule but lateral to the lateral ventricle. So this is the lateral ventricle over here, and lateral aspect of the internal capsule, there were putamen and globus pallidus externus and internus, collectively called as lenticular nucleus. Caudate and putamen is called as corpus striatum or just simply striatum. And in the midbrain part, this blue part, this is the substantia nigra, further divided into compacta and reticulata. Okay. So there are so many other structures. If we just take a glance through these different structures, see, if we do one section over here, so if we enlarge this one, again this part, lateral ventricle, caudate nucleus, internal capsule, thalamus, globus pallidus internus, externus, putamen, and this one is subthalamic nucleus, and this part is the lowermost, this dark one, this is substantia nigra. Okay. Now coming to the connection part, for the connection part too, it's like there are so many complicated diagrams within the book. I will advise you not to go to those diagrams, but before going to those diagrams, let me tell you, no, I'm not saying don't go to those diagrams. Before going to the book, try to draw two diagrams. I will tell you, try to draw two diagrams which is given in this slideshow. First is this one. Pause the video and try to draw the diagram on a plain paper as it is, like whatever the color, whatever the structure it is. Like there are few of the arrows which are clear, few of the arrows which are dark or filled or shaded, we can say. So try to copy it as it is present. Pause the video and draw this diagram. Once you are done with drawing this diagram, then start the video again and listen to me. See, I said at the starting of this class, there are, broadly we can say, there are the connections in between the ganglia, that's one. Second is, there is input that's coming to the ganglia mostly from the cortex, but there are other connections too, like thalamus also gives input. So that is the second one. The third one is, there is output from the basal ganglia. Most of them will be going back to the cortex. So we can say there is a loop formation. Like from the cortex it goes to the basal ganglia, within basal ganglia there is some connection, there is some pathway, and then via thalamus it goes back to the cortex. So there will be the loop. So these loops, they can be broadly divided into two parts. One is direct, other one is indirect. So if we go by this diagram, first we will look at the direct one. See, from the cortex it goes to the striatum. Forget about the shape of the arrow, just try to look at the boxes. First there is cortex, from the cortex it goes to striatum, right? From the striatum, what is striatum? Striatum is collective name for caudate and putamen. From the striatum it goes to globus pallidus internus segment. Forget about all other things, just try to look at the things, the name I am speaking. The cortex, from the cortex it goes to striatum, from the striatum it goes to globus pallidus internus, from the globus pallidus internus or internal segment it goes to the thalamus, and thalamus from the thalamus it goes to cortex. Forget about the supplementary or whatever, or just imagine, forget, like say from the thalamus it is going back to the cortex. So there is one loop: cortex, striatum, globus pallidus internus, thalamus, and then back to the cortex. This is direct pathway. Okay. The second one is indirect. Initially from the cortex to striatum, initial segment, it's same. From the striatum, instead of directly going to the globus pallidus internus, it is taking a long route, or we can assume that we are taking the bypass of a city, the outer ring road of the city. So in the outer ring road, from the cortex it goes to the striatum, from the striatum it goes to globus pallidus externus, and from the globus pallidus externus it goes to subthalamic nucleus, and वहाँ घूम घाम के then it comes back to globus pallidus internus, and then again the same pathway, the common pathway, from globus pallidus internus it goes to the thalamus, and thalamus to cortex. So it's like you are entering one city, a particular city, and then exiting that city by taking the bypass. From the cortex you entered at the initial segment, that is the striatum. From the striatum, instead of going through the city, you took the bypass outer road. From the striatum you went to the globus pallidus externus, and from the globus pallidus externus it goes to subthalamic nucleus. Then the last part of the city, that is globus pallidus internus, you exited the globus pallidus internal segment, then thalamus and cortex. So that is indirect pathway. Now look at the arrow, the shape of the arrow, whether this is clear or shaded. In this direct and indirect pathway, we will deal with neurotransmitter excitatory and inhibitory, and excitatory will be glutamate and inhibitory will be GABA. So first we will look at excitatory, not excitatory, look at the direct pathway. From the cortex, neurons releases excitatory neurotransmitter, that is glutamate. So if we stimulate the neuron or the cortex, what will happen? There will be release of the glutamate over the striatum. So what the glutamate will do? It will stimulate the neurons present within the striatum. They will get stimulated. Now what these neurons will release? They are releasing GABA, inhibitory neurotransmitter. We stimulate the cortex, which in turn releases glutamate neurotransmitter. Glutamate makes the neurons of the striatum to get stimulated. They will get stimulated. Now they will release the neurotransmitter, and that neurotransmitter is GABA. And where exactly they are releasing this inhibitory neurotransmitter GABA? They are releasing over the neuron of globus pallidus internus. So now what will happen to the stimulation of the globus pallidus internus neuron? They won't get stimulated, because more and more stimulation of the cortex, more and more release of the glutamate, more and more stimulation of neuron of the striatum, so more and more release of inhibitory neurotransmitter GABA. So the neurons of the globus pallidus internus won't get stimulated. So if they don't get stimulated, they won't release neurotransmitter over the neurons of the thalamus, and that neurotransmitter is inhibitory. So if there is less release of the inhibitory neurotransmitter over the neurons of the thalamus, they won't get inhibited, they will get stimulated, and ultimately thalamus neurons ends over the cortex. So what will happen to the cortex? It will get stimulated. So if we stimulate cortical neurons and via direct pathway, if we stimulate the cortical neurons via direct pathway, there will be more and more stimulation. Did you get it? Let me repeat it once again. If we stimulate cortex and we are talking about the direct pathway, then the neurons of the cortex ending over the striatum will release glutamate, which will make the neuron of the striatum to get stimulated, which will release inhibitory neurotransmitter GABA over the neurons of globus pallidus internus. So what will happen to the neuron of the globus pallidus internus? They won't get stimulated. If they won't get stimulated, they won't release inhibitory neurotransmitter over the thalamic neurons. So, if there is no release of the inhibitory neurotransmitter over the neurons of the thalamus, there won't be any stoppage of the thalamic neuron to get excited or stimulated. So, they will get stimulated and ultimately they are ending over the cortex. So, we can say this direct pathway is excitatory. If we stimulate more and more cortical area, there will be more and more stimulation via the direct pathway. There is one term that is called as disinhibition. Disinhibition. What is disinhibition? It is one population of inhibitory neurons inhibits the second population of inhibitory neuron. That is what is happening in this direct pathway. How? What is disinhibition? One population of inhibitory neuron means that one population of inhibitory neurons happens to be striatum. It inhibits the second population of inhibitory neuron, and that second population of inhibitory neuron in this pathway happens to be of globus pallidus internus. So, if we stimulate more and more the first population of inhibitory neurons, there will be more and more inhibition of the second population of the inhibition. So, ultimately their output will get cancelled, means this negative will get cancelled with the negative. So, if stimulate more, there will be more and more stimulatory output from the thalamus. That is direct pathway. Okay. So, remember the end product of this direct pathway is its stimulatory. Now, coming to the indirect pathway. Indirect pathway, first segment is same, from the cortex stimulatory goes to striatum. Now, from the striatum it goes to globus pallidus externus. Okay, before like completing this indirect pathway, just have a look. The output from the striatum, whether it is to the direct through the direct pathway to the globus pallidus internus or through the indirect pathway, it is always inhibitory, right? Always inhibitory. Output from the cortex is always stimulatory. Output from the striatum is always inhibitory. Output from the globus pallidus, whether it is internal or external, is always inhibitory. Look at this diagram. Okay. So, if there was no subthalamic nucleus in between, then the direct and indirect would have been same. See, in the direct pathway, cortex to striatum, striatum to globus pallidus internus, globus pallidus internus to thalamus. If there was no subthalamic nucleus, and indirect pathway from the cortex to striatum, striatum to globus pallidus externus, and from the globus pallidus externus, instead of this, remove this track, it was directly to the thalamus, then it was the same thing. But no, there is one more stoppage over here, that is subthalamic nucleus, and this subthalamic nucleus output is excitatory. So, just try to visualize this thing and try to understand in your own way what will be the ultimate output. If you stimulate cortex, it will stimulate striatal neurons, which will release more inhibitory at the globus pallidus externus. So, the neuron of the globus pallidus externus won't get stimulated. If they don't get stimulated, the release of the inhibitory neurotransmitter to the subthalamic nucleus will be reduced. So, what will happen to the subthalamic nucleus neuron? They will get stimulated more and more. Now, what will happen after the stimulation of subthalamic nucleus, more and more stimulation of the subthalamic neurons? They will make the neurons of the globus pallidus internus to get stimulated more, and globus pallidus internus neurons will release inhibitory neurotransmitter to the thalamus. So, what will happen to the neurons of the thalamus? They won't get stimulated. If they won't get stimulated, then these neurons are ending over the cortex. There won't be stimulation of the cortex. So, indirect pathway is inhibitory. Stimulate initial starting point, I will repeat it again. If we stimulate more neuron of the cortex, and we are dealing with the indirect pathway, if we stimulate, initial point is stimulation of neurons of the cortex, which will stimulate neuron of the striatum, which will release more and more inhibitory neurotransmitter over the neurons of the globus pallidus externus. So, neurons of the globus pallidus externus won't get stimulated. If they don't get stimulated, they will release less neurotransmitter GABA over the neurons of the subthalamic nucleus, and GABA is inhibitory. So, neurons of the subthalamic nucleus won't get inhibited, they will get more and more stimulated, they will release more and more excitatory neurotransmitter over neurons of the globus pallidus internus. So, in turn, globus pallidus internus neurons will get stimulated more and more, and they will release more inhibitory neurotransmitter over the neurons of the thalamus, which in turn will make the neurons of the thalamus to get less stimulated, and ultimately thalamic neuron are ending over the cortex. So, less stimulation of the neuron. So, indirect pathway is inhibitory and direct pathway is stimulatory. That is what we have concluded from this pathway. Is it clear? Now, I have tried to cover this diagram by drawing my hand diagram. This is one more diagram. Stop the video over here and then try to copy this diagram. This is also the same thing. See, from the motor cortex it is going to the striatum, from the striatum it is going to, okay, we will cover the direct pathway. From the motor cortex it is going to striatum, from the striatum it is going to globus pallidus internus, from the globus pallidus internus it is going to the thalamus, and thalamus it goes back to the cortex. This is one loop, that is the direct pathway, direct pathway. Okay. The indirect is from the motor cortex it is going to striatum, from the striatum it goes to globus pallidus externus, from the globus pallidus externus it goes to subthalamic nucleus, from the subthalamic nucleus it goes to globus pallidus internus, back to thalamus, and from the thalamus it is going to motor cortex. That is the indirect pathway. I forgot to draw one red line over here. Let me draw over here. 1 second. This line will go back to cortex. Okay. This will go, this is just assume this is ending over the motor cortex. Okay. This is indirect pathway. So, that we have covered in the previous diagram. Now, what is more in this pathway? There is one more connection, that is substantia nigra pars compacta. See, the green one is excitatory and the red one is inhibitory. You do one thing, stop this video, draw the diagram as it is in this colorful manner, the red one and the green one, and then try to understand the thing. If you don't understand, you are not able to interpret, or you get confused at some point, you can put it in the comment. I will try to explain it again. Okay, because nobody knows where you get confused, it is a bit complicated. There is one more pathway in this one, that is the substantia nigra pars compacta. Okay. Now, what is the connection of the substantia nigra pars compacta? Substantia nigra pars compacta, there are so many neurons, and out of those up to 90 to 95% of the neurons, they release dopamine neurotransmitter. In the previous diagram I said just remember two neurotransmitter, glutamate and GABA, but in this one, this substantia nigra, 95%, 90 to 95% of the neurons, they are releasing dopamine. Now 2 to 3% they will be releasing acetylcholine, few of them will be releasing this one serotonin. Okay, so forget about that thing, just remember dopamine. Now this dopamine which is getting released from the substantia nigra pars compacta, and it has got connection with the striatum. This is nigrostriatal pathway. Now this dopamine acts at the receptor D receptor. That receptor can be D1 or D2. If it is ending at the D1 receptor, it is excitatory to the striatum. If that dopamine binds to the D2 receptor, that is inhibitory. Forget about like why it is inhibitory, it might be autoreceptor or presynaptic. Just remember Dopamine binding with D1 is stimulatory, dopamine binding with D2 is inhibitory. Now, if we stimulate the motor cortex and we include this nigrostriatal pathway too, what will happen? Direct pathway was stimulatory, right? Like we stimulate the cortical neurons, it will stimulate more and more striatal neuron, which will inhibit globus pallidus internus, so which will less inhibit thalamus, and there will be more and more stimulation. Now, what will be the effect of dopamine binding with D1? If dopamine binds with D1, there will be more and more stimulation, means whatever the stimulation was happening because of the stimulation of neuron of motor cortex, it will add up. So, if dopamine act via the D1 receptor, it will stimulate the direct pathway more, right? And if dopamine binds to the D receptor, then what is this dopamine doing to the striatal neuron? It is inhibiting. Now we are stimulating via the motor cortical neurons, glutamate is releasing. This dopamine, when it binds to the D2, it will inhibit the neuron, striatal neuron. So, inhibit means there will be less release of the GABA over the globus pallidus externus. If there is less release of the GABA over the globus pallidus externus, the neuron of the globus pallidus externus will release more and more GABA over here. So, there will be less and less stimulation of the subthalamic nucleus. If there is less stimulation of the subthalamic nucleus neuron, there will be less release of the excitatory neurotransmitter over the globus pallidus internus. So, there will be less release of GABA, inhibitory neurotransmitter GABA over thalamus. So, thalamus was inhibiting the neuron of the motor cortex via indirect pathway. So, if there is less stimulation coming over here, less inhibition coming over here, then there will be more and more excitatory output from the thalamus to cortex, or we can say there is less and less inhibitory. So, via D2 pathway, D2 receptor, it inhibits the inhibitory pathway, and via D1 it stimulates the stimulatory pathway. Okay, stimulate the stimulatory pathway. Is it clear? If dopamine acts via D1, it stimulates the excitatory pathway. If dopamine acts via D2, it inhibits the inhibitory pathway, and that balance is needed. That inhibition and stimulation, that balance is needed for normal movement. If that balance gets deranged, if it gets more inhibitory or if it gets towards a more stimulatory, there will be either hyper or hypo excitation of the movement. That's all about the connection of this basal ganglia pathway. In the next class, I will try to cover different loops. So, today watch these videos, try to draw these two diagrams what I have told you, try to understand the things, then go back and read the book, and if still you are not able to get these pathways or there is any confusion, please write it in the comment. I will try to explain with the one more video. Okay. In the next class, we will cover the functions and pathology, as well as whatever the different loops. In some books they have given there is a caudate loop, there is a putamen loop. Once you are done with these connections, we will cover those loops too. It will become very easier. Okay, that's all.